It feels like you're doing the impossible, you know? It's like something that hasn't been done before. I mean, maybe, I don't know if there's been a search and rescue drone, but like, we don't know about it. I just like the feeling of doing something that hasn't been done before, you know? And also, I just like robots.
So the goal this week will be to find a lost drone out in the desert, find it and recover it and bring it back to the base station. And all of this, obviously, autonomously.
So I kind of wanted to see these things in action, get some experience with drones, figure out how to code these things, especially as drones are becoming more and more prevalent in society. Especially back home, Facebook is using drones to bring internet, bring resources to very hard to reach places in Kenya. So they kind of have a global context, which is why I was very fascinated and interested and wanted to get into it.
So this week we are revisiting a challenge we had in 2016, a drone challenge across 4 universities, University of Pennsylvania, Vanderbilt University, University of Arizona and UCLA. That was 2016. And the task there was to recover an object, which was an environmental probe, a mosquito trap. And during that event, one of our drones flew away, it was lost, and we had to go out and find it. So this year we took that lesson and we thought, why not make the goal of the challenge, no robot left behind. And that's what we are, this time we had 5 teams, 4 are actually here competing for the final stage, and their goal is to, with their autonomous drone, find a lost drone template. And the drone will detect it, recover it, safely drop it at a location and then land. And that defines the mission.
I was one of the first people that Dr. Butka talked about the competition. He said to get a team started up. So I knew a couple friends, and then I had some other friends that knew some friends. Yeah, so I started out, I did most of the software, but then I got Sean, he took over and cleaned up. I helped with the hardware, get it built, but then I had somebody else. Mostly I've just been like sourcing people and getting something started. But yeah, I guess I've sort of assumed the role of team lead.
I'm a computer science major, and I'm excited to see like the code and the real world cooperate together to complete some real physical tasks. And this challenge also introduced a lot of people who are new to this field, including me.
I'm just looking to learn about just how the development process goes, the failures and how we work through failures, how we come up with creative solutions in times where it doesn't seem like it's going to work, figure out how the integration of software and the physical parts work. I know in simulation everything works, but testing it out here is going to be an interesting time.
Well, me personally, I've never been to America before, so that's a big plus for me. That's great to be able to do that, like a cool project, and then also go to a new country. We're 6 engineers, 2 are electrical engineers, 2 are mechatronic engineers, and 2 are just computer engineers. Well, we've never used Linux before, so that was a big challenge, just understanding that. And then ROS in itself, and then the simulation was quite a big challenge as well.
The CPS website is a project that's been sponsored by the National Science Foundation. It started as an organization that was useful for helping organizations collaborate, share their information with each other. One of the ways that we helped with the competition this year was we provided a simulation interface so that students could join a group on the virtual organization, and when they actually had code ready, they could upload it through the CPS VO and run a simulation and download results afterwards.
The simulations, they helped us a lot. Without them, we would be much further behind. Testing beforehand is very important. And you control with pretty much just a couple of keystrokes, and you can do a lot fairly quickly.
There is a saying, simulations are doomed to succeed. So it doesn't matter how many successful simulation runs you have, when rubber meets the road, things start failing.
And we saw the evidence of that, and it was good to see that happen.
Oh yeah, I'm pretty confident. We know we can detect it very well. We can take off, do a search pattern, we can find that we found it. Localizing a GPS point has been our main challenge. We might have to switch to manual mode to do the actual pickup, but all that works. The autonomous picking up is more luck.
What I've observed is the collective suffering has encouraged them to talk to each other. For example, yesterday we had one drone whose Embry-Riddle Aeronautical University, the motor flew off, broke off mid-flight.
It took off, went upside down and crashed into the ground. We went, got it, fixed it, knew it wouldn't happen again, took off, crashed into the ground again. 3 of our motors were broken, one of them we didn't trust anymore.
So it crashed, they didn't have the component. Then UPenn, they gifted 4 motors. They mounted it within a matter of a few hours. They scoured for propellers, managed to do 4 runs, scored. And Embry-Riddle is now leading at 60. So it has become an interesting scenario.
I guess the bigger picture is to be able to cooperate in a team, like in a project group, and to see all the challenges that surface while doing that. That everybody was working together quite well, like very well. Some people were crashing their drones and stuff, and then people always try to pitch in and help each other out. Embry-Riddle, for instance, they crashed their drone basically entirely, but they built it up and still they did really well.
We just got 80 out of 100 points. It took off fine, did its search pattern autonomously, detected it autonomously. Our quad picked up the frame with us controlling it. We switched back into autonomy mode. It dropped where it was supposed to and then came back and landed exactly where it took off.
I am pleased about the fact that the teams learned a lot, they interacted with each other, they got the essence of the challenge. What are the pain points they can face, like temperature, heat, dust, lighting. They got a feel for it and it'll stay with them.